problems of the world are complex, and science ought to make a contribution to understanding them and managing them. Some of these problems that we're struggling with at the moment is crime, is war, the financial crisis, and also climate change. And there are no ready-made answers to these problems. So science is needed, and that means you are needed in order to address these problems. There is a classical approach to this, which is we sit down, go to a library, where we read books, study a lot, and eventually we come up with a new idea that would hopefully change the world to the better. And then politicians would take this idea, eventually put it into a law, and we would have also institutions in order to enforce this new law and basically change the world. But we'll have to pay for it. And it looks like actually we don't have the money for all this. So we have to be more efficient, and actually we need to use less money in order to solve the problems that we have. And that has basically led to a governance with big data. And some people may have not noticed that basically politics has changed. NSA debate certainly has raised some surprise, but in principle we really need to reflect about the new age of the internet and what the implications are, not just for science but also for politics. So rather than going to the library and reading a lot of books, you would go to the internet, you would make a Google search, Scholar Google or whatever, and there's a lot of information as we've seen. So big data means that there's 100 times and more of the knowledge of the biggest library in the world, the Library from Congress in Washington. We now have 700,000 search queries in a minute and 500,000 Facebook posts. And many more data that is accumulated in just 1 minute. So the question is, can we use this data in order to build a crystal ball? Just imagine this. So this is a thought experiment. If we wanted to do this, we would probably say, okay, let's get all the information that we can get. We'll find a question later on what to do with it and how to use it. I will start collecting information about our shopping behavior, not just online, actually also when we go to a shop, because we might pay with a credit card. We would track people's motion in space. We would look into their social graphs, and Twitter would actually expose what we think, what we want to communicate to others. But not only this, even those files that we thought were safe in Dropbox are broadly scanned for content, and the cloud probably as well, and even our email boxes. When this is done, not just for the sake of Secret Service activities, it's also to give us a service, to help us, to make us feel comfortable and allow us to work more efficiently. Also, when we read an ebook, this is being recorded. How much time do we spend on a page? What are we underlining? What is the content that we are really interested in? And Google would know what we think, because we would ask questions and Google would record it. Apple would record what we say, at least if we are using Siri. And it's also known in principle what we're watching, what we see will be known as soon as we're using Google Glass, so our environment will be recorded. And even in our living room, we're being observed by, for example, this nice game box. By now, even our fingerprints are recorded. So why don't we also collect genetic information? Again, this is a thought experiment, okay? And I think this is happening indeed. So we are ending up in a scenario that can be captured maybe by this kind of graph that over time you collect more and more information and eventually hope to have all the information in the world, and there are even companies called recorded future, a little bit cynical because it seems like we cannot take any free decisions anymore because everything is already recorded. It's known what we do. So is this the end of theory? Is big data a universal tool to understand and govern the world? Could we actually, with all these data, if we were in the government, could we take the best possible decisions? Could we do that in real time? Could we govern like a wise king or a benevolent dictator? That's a question that people, I guess, have been asking themselves. And so we need to reflect on this. Moreover, if we had all the knowledge in the world, would it imply superpowers? And of course, if you want to predict the future, you also need to have the possibility to influence what people are doing. So how would that happen? Basically, it's conceivable that we hand over personalized information to everyone, and by this kind of information that people get, we would steer their behavior. In fact, when you do a Google search, and in particular if you're logged in, then you get a personalized result. And many of the activities that you do on the web are recorded. Even if you don't want this, even if you didn't sign it, and we'll get a personalized feedback. And these days you see people walking around like this, and it's all the time actually, they're being influenced by our mobile devices. So perhaps this is the reason why young people don't protest anymore. I've seen many newspaper articles recently where journalists are wondering what's wrong with our young people. Yeah, maybe we're just scared by information. Now, the question is, would such a concept of a future governance work well? And I do think that there are reasons why the big data and the crystal ball approach often fail. First of all, you don't have really a clean data set. You have a collection of everything and contains a lot of garbage. You would look for patterns, for correlations, but it wouldn't tell you anything about causality. And it's a little bit like seeing these kinds of patterns in the sky. It's just our interpretation. And it's actually difficult to decide, is it meaningful or not? There are these spurious correlations, like a number of serial killers as a function of chocolate consumption. Now, if that was a causal relationship, then living in Switzerland would be really dangerous. So I feel okay. The other thing is, in many cases, you want to classify things, to good risks and bad risks, for example, but there's not a clear separation. So you would have overlapping point clouds, and that implies that you'll necessarily make errors of first and second kind. And you might also use the wrong kind of model. And as a consequence, you would make mistakes. And the question is, how serious are these mistakes? Here is maybe an even more important graph. So it shows you basically how processing power changes over time. See, every 18 months, look at the blue curve, processing power is doubling. That's Moore's law. And we will see later on what are the implications of this. However, if you look at the green curve, then data volume is increasing even faster. It's doubling every 12 months. And it means if you analyze this in a mathematical way, do a series expansion, then you will notice that within just 1 year, we're producing as much data as in the entire history of humankind. This is just mind-boggling. how to keep the overview. In fact, we can actually notice that while we have been in a situation of not having enough data to take good decisions, and we are now heading into this age of big data, where we can actually take evidence-based decisions, and this might improve actually our decisions and actions. But what we also see is that eventually the green curve overtakes the blue curve, and it's probably happened already a long time ago. And what does that mean? It means, first of all, we cannot process all the data in the world. And moreover, an increasing fraction of the data we produce, we can never process. So this is dark data that we'll never look into in the future. And it causes something like a flashlight effect. So we'll focus on something and we will not see other things that might be important. And for this reason, we'll do mistakes, and these mistakes might be really serious. It's not just, it's not entirely correct. We'll do terrible mistakes. So, Google Through Trends has been actually celebrated as one of the biggest successes of big data. And basically what has been done is they have been looking into search queries, tens of thousands, maybe millions of search queries where people say, oh, I have a headache, I don't feel well, I have a fever now, and all these kind of things. And then you correlate that with data from the World Health Organization, and you construct an index. And the advantage would be that you wouldn't have a delay of 2 weeks until you get the data. As it happens with the World Health Organization data, because you have to collect this data and it takes time. So Google said we can actually estimate in real time what's going on in the world. We call this nowcasting. But as you've seen recently, the quality of this approach has been called into question. And part of it is because the algorithms are changing all the time, and there's advertisement for medicine, all these kind of things that would influence people's behaviors and queries, and so it's not reliable. In fact, we've lost many months to respond to Ebola. It was already more than 6 months ago, it was clear that the industrialized world would have to respond to this, but we failed. We didn't pay enough attention to it. Also, the war on Afghanistan and Iraq ended in a different way than we expected. So if there is something that people would think might be a crucible, it didn't work so well. It didn't predict the financial crisis. It didn't predict the Arab Spring. It didn't predict all the trouble we have in Syria, and also the war in Ukraine. And the problem is that while we are focusing on one thing, like say fighting terrorism, something else emerges, like the financial crisis. And as we focus on one thing, we would overlook the other thing. And big data would also not give you an answer to new situations, like this one. Russian bombers going into all areas of the world, violating air zones and airspaces that they shouldn't enter. So how to respond to this? Big data will not give you an answer. You need better methods for this. And while we're concerned about all these things now, we're missing another big thing that's coming towards us, which is the digital revolution. So if you look at this graph, and it's basically showing Moore's law, you see that within about 10 to 15 years' time, computers will reach about brain power. They may not work exactly like the brain, but it's clear that they will be able to do many things that they've done in the past, and they may do it better. Like doing calculations, playing chess, and all these kind of things. And in fact, they're even better at these kind of TV shows. And they're better at accumulating information, like all the medical articles about a certain disease. No medical doctor can read all this, but IBM's Watson can evaluate it. So computers are getting better and better also in terms of regarding jobs that are highly qualified. Everything that requires routines, everything that has a certain logic might be done by computers or robots in the future. And so, besides this, we are exposed to the big data tsunami, and it's washing away certain kinds of companies. Kodak was just one example. They actually owned most of the digital camera patents, but they were not able to transform themselves quickly enough in order to be prepared for this new digital world. So what's happening now is basically something which is happening around every 100 years. We're seeing a transition in the way our economy and probably also our society work. And it's probably best understood by this graph over here. So it shows that we're coming from an agricultural society where most jobs were, of course, in the agricultural sector. And then the steam engine was invented. That caused the Industrial Revolution, and a lot of jobs were lost in this area. On the other hand, new jobs were grown, but much more slowly, as you can see. So the yellow curve shows the industrial sector and the jobs over there. And then again later, the service society came up as people had a better education, and there were public schools basically to prepare people to do qualified jobs. So of course, eventually this was filling the job gap that was occurring in the agricultural sector. Well, we know that was not a smooth transition, so it was really a challenge to our society. What's happening now is we see a saturation of the service sector. Experts predict that in the industrial and service sectors will lose about 50% of all jobs, also in countries like Germany or Great Britain, say within 10-20 years. And then that means we'll have 3 to 5% jobs in the agricultural sector, we'll have about 7.5% of jobs in the industrial sector. So if you look into an automobile factory, there are very few people these days. In the service sector, okay, we see 55%, say 30% in some years from now. That makes altogether 40 to 50% jobs in all the three classical sectors of our society, which means that 50% jobs are missing. Of course, there are new jobs in this new upcoming sector of the information and knowledge sector. The question is, will we be able to grow these jobs quickly enough? And if you talk to people in Silicon Valley and elsewhere, well, they should know, they would say, that might be really a problem, because many of these tech companies don't have a lot of employees. They're extremely efficient. So we might face a situation where we just don't have enough jobs for all the people. And somebody, of course, first to earn the money, also for the public sector. We will probably run into big trouble if we don't come up with a solution for this. I will run into this trouble pretty soon, and maybe we are already in this trouble. If you look at the youth unemployment here in Europe, then you can see that since the beginning of the financial crisis, things haven't really improved. On the contrary, it became worse and worse in certain countries. So if we believe that we'll be back to normal after the financial crisis, and nobody knows when after the financial crisis will be, if you think we'll back to the time that we had before, I think it's a big error. And we're in the middle of a transformation of our economy and society. And this is one of the questions that scientists should really focus on, because it will require new answers and solutions. So we'll probably see transitions in many areas of the world. We'll see that Africa is turning from an agricultural society into societies into industrial societies, that China might turn from industrial to a service society, that countries like the United States, European countries, Japan, Singapore, Australia might turn from service societies into digital societies, whatever that means. And this is exactly the question that we need to think about. What does this mean? So let's look back now. What turned the age of the automobile into a great success? It actually required a number of things. First of all, we needed to learn how to refine crude oil to get petrol. We needed to learn how to tame the forces of explosions, of burning this petrol, so we had to invent motors, which turns an explosion into a directed and controlled motion. We would have to learn how to assemble cars, how to build them efficiently. We have to build public roads, petrol stations, parking lots. We'd have to come up with driving schools, driving licenses, and also speed limits and all these kind of things. And also some authorities to make sure that traffic laws would be followed for the sake of safety. The question, what are the institutions for the digital age to come? We're spending billions on the agricultural sector, we're spending billions on the industrial sector's infrastructure, like public roads. We're spending billions on the service society, like public schools, public universities, and so on. Are we spending enough money on the infrastructure and institutions for the digital society? I don't think so, actually. And this is very concerning. So we must be aware we will have to build public infrastructures for the digital society. And so the question, what would be this public infrastructure? Now again, it helps to look back to understand what might be the trend into the future. So for this, it helps to go to this wonderful computer history museum in California, in Mountain View. And yeah, it all started basically with a few computers, and IBM chief Watson thought there will be a world market for maybe 5 computers. How wrong he was. Eventually we started to network computers. ARPANET was created to connect military computers, but eventually this networking approach was opened up for public use. The internet was born, and with this going public, many wonderful things happened, and in particular, a huge market grew. Then the World Wide Web was invented. Tim Berners-Lee came up with the HTTP protocol to connect web pages with each other. That turned the internet into a non-expert system. Everyone could use it and could be commercialized. And then it grew bigger and bigger to involve people through social media, so we're becoming nodes of this global information system. We're producing data, but we're also processing information, we're crowdsourcing, we're part of this global information system. And now things also are being connected to the internet with the Internet of Things. So in about 10 years, we'll have 150 billion sensors connected with the internet. 10 times more than people, even more than that. So in this room, we would probably have a few dozen sensors, just to make you aware of what that means. And so the question is, would there be anything that would not be noticed? Would there be privacy, for example? So now, basically, we're entering these times of the Internet of Everything, and we have these verbal computing devices that connect us more and more to the Internet, or that connect our bodies to the Internet almost. So we can say that basically it's not that things were going into a more and more hierarchical structure, which I've argued wouldn't work well. Yeah? But we've seen that instead the Internet has been involving more and more of our world. So it became a participatory system, a more and more participatory system. It reached out for people. It created new opportunities for people. And so the question is, what would be the next steps? And what would we have to do in order to use this information infrastructure in the right way? What would it take to turn the information age into a big success? And I think it requires us to change the way we are thinking about the world. Of course, information is a particular good. It can be reproduced as often as we like. It's not scarce. We wouldn't necessarily have to have battles about it, because it could be more or less an unlimited resource. And there are many other things that actually will change the way our world works. So there is a new logic of success in leadership. If we try to apply the success principles of the 20th century to this digital age, you'll fail. You'll have to learn to think in a different way, understanding how this information society works. And so I'd like to advertise a new approach, which I call Measuring the World 2.0. Would not be based on collecting all the data that you can get, have then a huge but dirty data set, which is not representative, and you wouldn't really know how reliable is it, how much you can rely on the results of your analysis. And in fact, somebody once said there is butterfly science and there's physics. So all science starts as butterfly science, which means start collecting data and classify what you find. But eventually you would have to learn to come up with explanatory models. That means a formula or something like this that would really allow you to understand what's going on in the system. Yeah? So we cannot stop with analyzing the data. And we need to have measurement devices, because the success of science was that we learned how to create measurement devices that would measure exactly the thing that we wanted to learn. And these are often very sophisticated measurement devices, not one universal device to measure everything. The measurement process must be adjusted to the question. This is important. And you may know this wonderful book, Measuring the World, and it's in particular about Alexander from Humboldt, and he was really traveling the world, and he's also the father of our university system, by the way. So important, of course, was that there were instruments to explore the world, to discover it, such as telescopes, and later on also microscopes. So this is how new countries were discovered. And in a sense, we are in a time when we can discover a new world, which is the digital world, which is about to emerge. It's a new kind of world. And this is extremely exciting, because we can do as exciting work as Alexander von Humboldt. Just to give you another inspiring example, the Hubble Telescope is being able to show us so surprising, mind-boggling things that are going on in the universe. It's shown us things that we couldn't really see with our own senses. So it makes invisible things visible. And maybe one of the biggest success stories is Konrad Röntgen's discovery of the X-ray. Because he could not only see things that he couldn't see before, he was also able to discover where things are wrong, where something is broken in the system. It helps us until today to heal diseases. And in a sense, now, our society is suffering of diseases too. As I said in the beginning, crime, conflict, war, financial crisis, you could consider this to be diseases of our society. Could we build a measurement device that could diagnose these diseases before they break out? Could we stop these diseases if we had the right device to diagnose it? And I do think it's possible, and coming back to this issue of explanatory models, I don't think we are in a world where big data is leading to an end of theory. As I said, we need explanatory models. I think we're making good progress in terms of understanding things that before were not understandable by mathematical formulas. Including, by the way, epidemic spreading. So this is a recent science paper with Dirk and what you find if you look at spatial temporal spreading patterns is a really widely scattered cloud of data, which basically shows you that spatial temporal spreading is pretty chaotic and pretty unpredictable. It doesn't seem to make any sense. However, it turns out that the reason for this is the trouble activities with airplanes. And if we use the data of these trouble activities, we can define a new effective distance. And if we apply this, then suddenly we get linear interdependencies that make the spreading predictable. We get, from the point of view of the origin of the disease, a circular spreading pattern in this effective distance. This allows us to do two things. We can first of all look at the disease data of the World Health Organization from all the airports in the world. And one of these patterns will be most circular. This identifies as the origin of the disease, which is often not known in the beginning. But it's very important to know this origin of the disease in order to detect, now, why did it break out in the first place? How does it spread? The other thing is, taking this together with the circular spreading, you can make predictions. You can predict what are the likely next cities to be hit by the flu wave. And you can deploy doctors and immunization doses and medicine over there in order to be better prepared and contain the disease more efficiently. Besides this, we came up with pedestrian and crowd models, with models for traffic flows. So there is an analytical theory despite the complexity of the problem. We have worked on the vulnerability of power grids to cascade failures and blackouts. We've worked on the resilience of the European gas supply, social influence opinion information, self-organization of behavioral conventions, cooperation, the evolution of moral behavior, the evolution of social preferences, the emergence of social norms, and the occurrence and spreading of conflict. So all of this can be analyzed by means of mathematical models that give us better insights into what's happening. And it's also helping us to look at so-called counterfactuals into scenarios that we might decide for. So in this case, it's about conflict in Jerusalem, in the Middle East. So there is a political discussion about possible means how to reduce conflict. Now we have tools that help us actually to judge different kinds of scenarios. Now, in order really to make these models useful, it's important to have data, and there are a number of possible approaches to have really systematic collection of data. And one of them is lab experiments, and we're doing this, of course. And there are new opportunities coming up through interactive games, which might also be used as experimental platforms. And in fact, we're often doing web experiments these days. But maybe the most important measurement device for real-time data of the future is what I'd like to propose now. And of course, I will not be able to build it myself. I'll need your help to build it. And it will give you many new opportunities for science. We call it the Planetary nervous system. And all it takes is you and your smartphone. Because we can connect these smartphones to build a global measurement system. So, of course, you would now start to get concerned about your privacy. You know, if we open up the sensors of your smartphone, would we listen to what you're saying? Of course not, because we are taking a scientific approach. And so it's good to be inspired by this CERN, because this is, you know, the measurement device for elementary particles. We want to build a measurement device for techno-social economic systems for our society and economy. So what does the CERN do? They throw away 99.9% of the data that they create. They just keep a very small share of the data, and they do it independent of the experiment they're doing. It's a tailored, intelligent measurement approach, which really depends on what is it that you need to focus on. You're not just measuring everything. You're measuring in a very targeted way. And we would do the same thing. We wouldn't collect all your data and try to keep all the data in the world. We would create a tailored measurement infrastructure that can be used in different ways. It's very important for you to join in, that you can trust this infrastructure. Not the Secret Service, which can open up your smartphone sensors even if you turn off your smartphone. We don't want to be a Secret Service. We want to build an infrastructure that you would trust and you would benefit from. So it's important that we respect privacy, and that we give you ownership over the data that you produce. And there is this open personal data store concept developed at MIT, which I think is pretty promising for this. But most of all, you are in control of the data stream. So you can really say, okay, I turn this sensor on and off. I'm using it just for my own purpose, or I'm willing to share these data. What we hope is that you would recognize that contributing to the measurement of our world would be to the benefit of everyone, including yourself. So you wouldn't just turn all these sensors off. We would also take care that we use these sensors in a responsible way. So the challenge is, to come up with a privacy by design approach. For example, what we do is you're not just opening up your microphone because you wouldn't want to be listened to, okay? So we degrade the sensor by a low-pass filter. So we couldn't hear what you were saying, but we could still use it as a noise sensor. And if enough people would open up the noise sensor, we could measure the noise distribution in your city, in any city in fact, as a function of time and space. So this is the kind of use we could do, and you wouldn't have have to be concerned about it. So we've started with this. We're opening up these sensors, and you can see we're reading out a number of variables here. And these are, for example, accelerometer data. What could we do with them? Well, first of all, we could do a collective measurement of road bumps. Yeah? If always at the same place you have this movement of your smartphone, and the city authorities would know, okay, we need to fix the road over there. It would be much cheaper to fix the road because you don't have to drive along all the streets. So you get this information basically for free. Same thing, we could collectively sense earthquakes. We could warn our friends and colleagues a few seconds before it arrives hundreds of kilometers from our location, so it might help them actually to protect themselves. This is the kind of thing. So the main point about the system is it should be open, transparent, and participatory, because you want to create new opportunities for everyone, for business, for politics, for science, and for all the citizens. That means all of us. So we would build this system, but how would we build it? And I think it makes a lot of sense to build it as a citizen web. I mean, we would build it. We would build it, and the approach would be that we would make contributions, similar as we do that with Wikipedia, for example. And it works pretty well, as we know. So that would be a real-time data Wikipedia about the world, in a sense. And it would be based on the principle of give and take. Yeah? So you could take data that people have made available, but in exchange you would contribute own data. And the same thing actually happens also with algorithms that you could use in order to make use of these measurements. I mean, the measurement protocols and kind of things, you know. So in my institute, we could come up with 10 or 20 measurement protocols. But that's it. If we have a community of people, and everyone comes up with one or two new kinds of measurement, you know, within a very short time, it will be a very powerful system that's useful for everyone. And in particular for really exciting science. But not only this, it would create an information and innovation ecosystem. Because, yeah, you could actually even use that for business, and I'll come back to this later on, actually. So the idea is that we would scale it up. We start local, and like OpenStreetMap, it would spread all over the world because it's useful. Yeah. So I'd like to encourage you to become part of this community. We're going to create a number of hubs in all major countries in the world. At the moment, we don't have separate money for this, but you know, if you decide this is so exciting and your team should join in, you would spend some time of your team on this and make a contribution. We create some measurement protocol. We would grow it over a few years. It would be really a powerful thing. And this is not a dream. We have started this already. So there is a young team of really dedicated, cool people who are working on this. And by the end of the year, we expect that we have a core of this. And then the community will be able to join in all these apps that I was talking about. So this is extremely exciting. You could also actually connect external sensors with this, you know, like humidity sensors if you want to know how is your plant doing, do you need to water it, all these kind of things. You might come up with all sorts of ideas that we might not even think of. This is the opportunity of a community approach. It's going to create just mind-boggling new possibilities. And it's a lot of fun. So we'll gamify it, there will be an incentive system, it will be open. So if you buy a box box with sensors. There would be a web page where you can download software to run it on top of these sensors. You could make measurements from the very first day, say at home. And then one day you would think, wow, couldn't we use this also for something else that you have in mind? And so you think I should really try this, but you don't know how to do it. But you can download the source code, right? And then you get your friends together, sit around your computer, and you would figure out how to do that together. But as you've taken the code from the web, you would also share your code with the web. So eventually it would grow, and it would start maybe more like a game, but eventually we would have a micro-payment system, and we could use the same infrastructure actually to come up with services and products. So I told you we'll have this problem that 20, 30, 40% of jobs will be missing. So we'll have to basically create our own jobs. Maybe not we, maybe you, I don't know. But many people will have to create their own jobs. And this data platform is going to create opportunities for everyone to come up with new ideas, new services, new products, to self-employ yourself, to come up with your own small company. And the more companies are being formed, the more opportunities are being created. So this creates this innovation and information ecosystem, and we need to grow this quickly because we'll need these job opportunities now, in fact, and even more so in the future. Well, 3D printing and other technologies is actually promoting this possibility that you can now produce some things yourself at home. So you can get your friends, colleagues, some experts together from your own city, from all over the world, and come up with a new design of a cup, of a lamp, maybe even a car, who knows? It's the first 3D printed cars, actually, and it's incredible. So there is a new industrial revolution going on. And so what could we use this new measurement device attention system for? So first of all, create awareness. Awareness of positive and negative externalities. It means of our situation and our impact on the world. We could map social capital to protect it, trust and solidarity, not just measure economic growth and GDP, but also education, the state of our environment, and all these things will be measurable in a detailed and cheap way. We can map change and who causes it. We can map resources and who uses them. We can look into the resilience, for example, as we've done of the European gas supply. We can come up with real-time financial risk maps in order to reduce the risk that we would have large bubbles imploding or collapse even of the financial system. And a little bit pessimistic actually about the state of our financial system. We can also measure tension, even international tension, and we can measure and predict disease spreading. But also positive things like the creation of ideas, the spreading of ideas, knowledge production and consumption, and the emergence of new concepts and how they spread. That will be coming up very soon in Physical Review X. We can also map culture and how it spreads, and we should focus more on the success principles of all the cultures in the world. So there are a lot of things that we're not sufficiently aware of. But not only this, we could also, with this real-time measurement data, enable self-organizing system by real-time adaptive feedback. And here should be a video that's unfortunately not running over here, but you can find it also in our Computational Social Science YouTube channel. So what we've done is basically come up with real-time measurement and feedback concept together with Volkswagen, so this is not theoretical, where we have radar sensors measuring distance and relative velocities of the cars, and where we have the cars drive automatically. We did that 7-8 years ago when Google was not yet talking about Google self-driving cars. So what we've done here, we have changed the interactions between cars in such a way that it would stabilize the traffic flow and increase the capacity of the traffic flow. So we made sure to create a collective effect which is desirable by modifying the interaction. Same thing with urban traffic flow. We came up with interaction rules and real-time data feedbacks that would create automatically, by self-organization, green waves. And if I had more time, I would show you that this is, surprisingly enough, more efficient than our today's top-down approach, because traffic light control is an NP-hard optimization problem. It's too complex to be solved in real time. And so, in such a system, which is dynamic and complex, hardly predictable, largely variable, and not optimizable in real time, it's more important to flexibly respond to the local needs. And this is what we've done, and it works so efficiently that actually all the participants of the traffic system and also the environment would benefit. In fact, it has just been implemented at a few traffic lights in Dresden, and it works wonderfully. Now the question is, could you also apply such an approach and transfer it from technological systems to our economy or society? In fact, it's already happening in production. It's called Industry 4.0, but it will not be constrained to factories. It will spread to other areas too. And in fact, Nobel Prize winner Elinor Ostrom has shown with empirical studies that self-governance can be efficient. Again, given you have the right interactions in place. So it's a matter of systems design. And this is the challenge for complexity scientists, to figure out what would be the right kinds of interactions in institutions. Well, reputation systems could be one such mechanism. They can be beneficial for buyers and sellers, and actually they're spreading quickly on the internet because they're so useful for us. I think, though, that we need to improve these systems. Of course, they're not preserving socioeconomic diversity. They tend to create hypes. They're vulnerable to manipulation in the way we are running them today, and so we need to improve these kind of systems, and I have ideas how to do that. We can further on come up with new social information technologies that would help us to master our lives better in a complex world. And in fact, diversity and complexity are challenges. But in principle, if you interact with somebody else, or two companies interact with each other, there are just four possibilities. There could be a lose-lose situation, which is not good for anyone, so you should avoid this. It's a matter of awareness. So, but it could also be win-win situation. Then it's just a matter of how do you share the gains. There could also be win-lose situations, though, and there are two kinds of them. In the first case, altogether, there would be a loss. But one party would like to engage into it and exploit the other party. So as this is creating a systemic damage, we should avoid this. And in the good win-lose situation, one party wouldn't be interested in engaging in the interaction, but we can turn it into a win-win situation by a value transfer. So basically, we need social information technologies to improve the situational awareness, to facilitate profitable interactions, avoid lossful interactions, and incentivize favorable interactions through value transfer. And actually, it's a patenting process. And finally, there is a third important application of the transient nervous system. It's a nervous system, so it's something that allows you to create intelligence, and in particular, collective intelligence. Because, as I said, the problems in the world are complex. They're too complex, in fact, for a single mind or a supercomputer. We cannot understand them anymore in their full complexity. If we don't manage to grow new, bigger, more powerful intelligence, we can do that only, basically, if we go away from this idea. It could be this one powerful thing, like this antenna. This area of small antennas is actually more powerful than this big antenna, right? And here is an example where basically we all together can create a picture, a 3D picture actually of our entire world. These are positions where photographers have been standing, and these are the points where their cameras have been pointing. And you will see that with Flickr photographs on the web, you can reconstruct the Colosseum in Rome, and in fact you can reconstruct any place in the world that people take pictures of. And you can do that even in real time. So basically, this is the power of crowdsourcing. We together, and only we together, can actually create a good picture of the world. And for this, we need to bring the best ideas and the brightest minds together and connect them. The question is how? Well, we can learn a lot from the Netflix challenge. Now, this was about $1 million. Netflix wanted to predict the view habits of their video viewers, of their customers, and it turns out to be pretty difficult, despite all the machine learning and big data and technology. So I think they made about 10% of correct hits. And I say, okay, if you can improve it by another 10%, we'll give you €1 million. And it took more than 2 years, actually. There were thousands of proposed solutions, there were hundreds of teams. And then after 2 years, the boss of the leading team stepped into the room and said, hey guys, don't you think we should focus on another task? And I said, okay, no problem. Now we need to take another strategy. So what they did is the best team teamed up with other teams that weren't so good. And they averaged over their predictions. You would think, okay, then the prediction would be worse, because it was averaged with inferior predictions, with inferior solutions. But on the contrary, the solution was better than the best solution. So diversity wins, not the best. And this is mind-boggling. So we need to go away from top-down decision-making, because this is just the intelligence of one mind or one supercomputer. Majority decision-making is better because it takes more ideas on board, and this is why democracies are pretty successful. But we need to take even more ideas on board. So how would we do that? Well, with the transient nervous system, we're reaching out for everyone. And so get ready, take out your smartphone from your pocket, team up with your friends, and improve the world together. Thank you very much.